What is the future of oil production today? Oil fields or reservoirs are invisible, and their access is more and more difficult, buried as they are under thousands of feet of rocks, which are sometimes even covered by sea. As an ultrasound scan shows the shape of a baby in its mother's womb, today new techniques allow us to penetrate the secret of the Earth's crust. The rule is, look for the trap. Areas likely to contain hydrocarbons can be seen from space. A sedimentary basin, a former delta, or an old river valley are signs of hydrocarbon traps. Aerial photographs and detection from space give information which leads to the choice of regions where it's worth starting surface exploration. This exploration begins by measuring the propagation delay of an underground shock wave. Operators cover the area to explore with GPS. They set up lines of acoustic sensors, geophones. Huge trucks equipped with vibrators weighing several tons follow these lines. At regular intervals, they generate a seismic wave. The wave propagates underground and reflects on the various geological layers. This method, called seismic, is the most efficient for discovering the arrangement of the geological layers and consequently the potential traps for hydrocarbons. The signals are detected and treated locally by mobile laboratories. The first analyses of these results are sent on tapes or directly transmitted by satellite to the data center. A similar technique is used to explore the seabed. Boats crisscross the area to explore, pulling in their streamers equipped with hydrophones and air guns that generate seismic waves. A network of satellites, data banks, computer servers and data interpretation centers gives the engineers direct access to the data collected. Precious knowledge acquired from previous drillings is included in a gigantic database.
Data recorded in the field are verified.
By comparing these data with those collected in the explored zone, the geophysicists will be able to recognize the geological structures that characterize hydrocarbon traps. Their first job is therefore to determine on the seismic charts the nature of the various layers the waves pass through and trace their outlines so as to obtain a three-dimensional representation of the subsurface structure. By putting together the slices of the field studied and extrapolating the data, a first visualization of the reservoir appears on the screen. This picture is analyzed and discussed by the seismic specialists, geologists, petrophysicists, drillers and petroleum engineers in order to decide the location of the first exploratory drilling. The results are used to refine the first hypothesis. During drilling, a set of tools equipped with sensors measures various parameters: gamma radiation, nuclear magnetic resonance, induction, pressure, resistivity, from which certain characteristics of the layer can be deduced, like permeability or porosity. The collection of this data, called logging, is an important part of the process. It confirms the existence of oil. In this case, a new series of more precise measurements is taken in the well. This time the distances are measured to the nearest centimetre. These results are transmitted on the network to the experts working in interpretation centres called eye centres. They work on a picture where the results of the logging are visualised. This picture can be rotated in all directions.
Okay, so if we come in here and try and expand this section here. Okay, so we've got a stand.
The result of the logging is promising. The decision is taken to exploit the reservoir. The eye centre intervenes again. The three-dimensional display allows the specialists to determine very precisely the trajectory of the drilling for exploitation. They penetrate into the heart of the reservoir. Here the well penetrates into a high-pressure area rich in hydrocarbons, shown in red on the screen. The technicians determine its route, staying as close as possible to the reservoir, even in the narrowest part, to reach another high-pressure zone. Once the well is described, they verify that its route does not deviate from the producing layer.
Yeah, it's very good.
Drilling costs more than 60% of the prospecting campaign investment. It's now possible to drill in any direction, including horizontally, and thus exploit even the most hidden recesses of the reservoir. About 50 wells can be drilled from the same platform. The investment has to be profitable. The eye centre is also becoming the essential tool for making economic decisions. Video conferencing links the driller on the rig or the client in his office with the team of specialists who can react quickly to the information. The reservoirs in production are thus re-evaluated at regular intervals. Well monitoring is done in real time by applying the same methods to exploitation as those used in exploration. Oil is a precious resource that must not be wasted. Today, the hydrocarbon recovery rate is approximately 35%. According to the experts, a 1% increase is the equivalent to 3 or 4 years of worldwide consumption. The goal is to reach a 65% recovery rate. Imaging a reservoir, picturing the invisible, allows us to meet future challenges. Optimal reservoir production, lower production costs, and therefore meeting energy needs for the decades to come.